We mentioned in the last video that ISIS packets are called Protocol Data Units, PDUs, and ISIS uses the following PDUs to exchange protocol information. The Hello PDU. These are used to discover ISIS neighbors on a link, decide whether the adjacency is level 1 or level 2, and once the neighbors are adjacent, the Hello acts as a keep alive to maintain the adjacency and to inform the neighbors of any changes in the adjacency. These hellos are sent every 3 seconds by the DIS and every 9 seconds by every other non-DIS intermediate system. On a broadcast network, hellos are sent for both level 1 and level 2 intermediate systems, but on point-to-point networks only a single hello packet is sent. Level 1 and level 2 hellos are delivered with the multicast address shown on the screen. Link state PDUs. Also called LSPs, an intermediate system generates a link state PDU to advertise its neighbors and the destination that are directly connected to the intermediate system. These are usually sent when an intermediate system discovers that one of its neighbors are down, or it has a new neighbor, or maybe the cost to an existing neighbor has changed. Sequence number PDUs, SNPs. These contain a summary of one or more LSPs. There are 2 types of SNMP for both level 1 and level 2. Partial sequence number PDU. This is used to list the most recent sequence number of one or more LSPs and can be used to either acknowledge the receipt of an LSP or request details for a missing LSP. CSNP. Complete sequence number PDUs send a summary of the entire link state database that an intermediate system has for a given level, and these are sent periodically or when a link first comes up. This ensures that the link state database for all intermediate systems are always the same. TLVs. Type length value fields. IS.IS PDUs have the ability to carry TLV encoding. But what is a TLV and what does it do? In the ISIS packet, there is a fixed part of the header and a variable part of the header. And the variable part of the header is where the TLV resides. This allows ISIS to be extremely flexible and add new header information without modifying the standard header. For example, the TLV of 1 to 8 was added to ISIS to enable it to carry IP information, and 2 additional TLVs were added to support IP version 6 routing, TLV 232 and TLV 236. Looking straight into this lab, following on from the last lab which we were looking at L1 and L2 levels for ISIS, and we have all 5 routers, all 5 intermediate systems, but we'll probably only use the first 3, VMX R1, VMX R2 and VMX R3. And the first thing that we're going to try and look at is the intermediate system to intermediate system Hello PDU. So let's have a look at R1, which is here, and let's just jump on. And what I will do, I will configure some trace options under the IS-to-IS protocol, and then we're going to have a look at some logs and see if we could see those MAC addresses for the level 1 and for the level 2. Set trace options. Our file will be called, we'll just trace ISIS, and we're going to set our flags as the hello packet, I would have thought it would say. Yeah. Now we're currently running ISIS in broadcast mode, so I would expect to see on R1, which we've disabled level 2, so we're expecting to see hello packets being sent to the MAC address ending in -14. Run, show log, trace ISIS. And we do. So we see that a periodic hello is being sent to the multicast MAC or the MAC address of 01. I say in a MAC address, but it's probably a multicast address. I can't remember at the moment which one it is. Sorry for that. But anyway, we know that it's 01 80 C2000014, and if it was being sent to level 2, that will be 15. And we could also see that it's being sent every, what is this, 23, and the next one is 31. So it says in the documentation every 9 seconds, but it will be less than 9 seconds because it's a random number less than 9 seconds because it tries to avoid the synchronization rule. And we know if this is being sent every 9 seconds, I just want to ask you a question. Is this a normal intermediate system router, or is this the DIS? This must be a normal one because we know that the DIS sends it every 3 seconds and the other routers send them every 9 seconds. So to prove that, I would expect now when I do a run show ISIS interface that it will say it's the DR, the designated router, which is the designated intermediate system. Could be wrong, but I doubt it, unless the documentation is wrong. Run show ISIS interface. Yeah, and we're seeing that R2 is our designated router. Now, what I'm going to do, it will bring down the adjacency, but I'm going to configure this interface as a point-to-point interface, and let's just see if there's any differences. So set interface GE0. And when you set it to point, it will make sure that there's no designated intermediate system. So that should bring down the adjacency because I don't have it running on the other side. Yeah, let me just jump onto R2 and bring that up. Yeah, and we now see that the interface is up. A couple of interesting points here. So our SNMPA has disappeared, which is interesting. Let's have a look at the trace file as well. It's something network point of attachment. What is the S stand for? I can't remember. So run show log trace ISIS. Okay. Oh, a couple of things here. So it says that we've received a point-to-point intermediate system to intermediate system hello from VMX R2, but the address has changed, which I didn't realize. I thought it was, so for broadcast networks, we know that it sends it to 0180 C2000014, and on point-to-point networks, it sends it to a different address, which is 0900 2B000005. Okay, so that was worth doing it just to realize that. Let's move on. The next ISIS packet that we're going to look at is the LSP, the link state PDU. And to see the link state PDU, before I begin that, what I'm going to do, I'm going to change things up a little bit, because on a multimedia access network, you're going to get 2 LSPs, one for the DIS and then the normal one. And what I want to do, I want to change I reverted it back from being point-to-point, I think. I'm hoping it is still point-to-point, actually. Because if it's point-to-point, then we don't even need to have this conversation. Because there isn't a DIS, basically. So let me have a look. Yes, okay. So it is point-to-point. So what I will do, to look at the LSPs, and an LSP, a link state PDU, is generated to advertise like a intermediate system's neighbors and its connected links. And to do that, we're going to have a look at the IS-to-IS database. If I do run show ISIS database for VMXR2 and look at the detail, these are what is being advertised to us from R2. And we can see that all its connected links. So on R2, it's got its loopback. There's a connection to us. We can see that there's a connection to R3. And it's also saying that it has another interface, a 100.1.100/32. Yeah, so that must be a directly connected loopback on R2. And let's verify that. If I go into R2 and say, oh, it's right here. So it is a directly connected interface, which is excellent. And that is our LSPs there. And if we just looked at the database without the detail, we can see how many LSPs we've got. And I'm expecting to see only one. Okay, we're seeing 2 LSPs, none for level 2, and one coming from R2, and then our LSP as well itself. And we can see also with this attached bit here that we're seeing a default route. So let's have a look. Run, show. So that means that the L1, L2 is sending us an attached bit, and we generate a default route to get to other prefixes in different areas. The next thing, and the last thing I'm going to do, is we're going to look at the complete sequence number. Now, we could look at the partial sequence number, but the only way that I know how to do that is by looking through a Wireshark capture. But we do know that the complete sequence numbers are sent out periodically, so we should be able to have a look at those. And to do that, I need to set up some trace options. So I've got it flagged for the LSPs. Oh, we didn't look at the LSPs, so let's have a look at the trace option first for the LSP. So run, show, log. Receiving an L1 LSP, and we're updating that LSP. And these are the LSPs that we've got. We're also sending our LSP on interface GE000. Let's clear that log. If I say exit, then exit again, and say clear log. Let me edit this. Edit protocols ISIS. Let me delete that. Delete trace options, flag LSP. I'll commit that, and then I'm going to clear the log. If I clear the log of the trace ISIS, if I do a show log now, it should just show that it's cleared, and then we reset the trace options. Edit protocols ISIS, set trace options we're going to put the flag for the CSN, which is the complete sequence number. PDU, commit that. Run show log trace ISIS. And here it is. We can see that we are sending a periodic complete sequence number on interface GE0000, and this is the range of the LSPs, and we're sending that over to R2 periodically every, it looks like it's being sent out every 5 seconds. All right, that is it for the ISIS protocol data unit. Let's move on to the next lab.